Example number 4. Instead of working with equations, terms, substituting numbers, there are times when the function given to us would just be a graph. And we will be using the graph to answer questions. So here in example number 4, we don't have an equation to work with, but using this graph, you will be able to find the output when x equals -2. You will be able to find the output on your graph when x equals -1. So you'll be using your graph. Identify the points when x equals -2, when x equals -1, and when x equals +2, and using your graph, what is the output on your graph? What does it mean when it is the output? Is it the x or the y? The y. So you will be finding the y coordinate on your graph when x equals -2. On my graph, here we have -2. And the point that is on my graph give us +1 for the y coordinate. So that's what we have. So for the next one, Fauna, when x equals -1, what is the y coordinate? Do you see more than one thing? No? We only have one answer, right? And what will be your answer? -1. When x equals -1, it seems like we have two answers, but one of them comes with an empty circle. We don't count them. Yes, we don't count them. We will only count the point that give us a solid dot. So in this case, we only have one answer, -1. If you've done your worksheet from the previous lesson, domain and range, you will be able to understand the difference between solid dot and empty dot. Nicholas! What about the next one? F of 2. When x equals 2, what is the output from your graph? When x equals 2, here is x equals 2, there is only one point that you'll be using on this graph. Would you be using the point up here or down there? The one up there. And what is the output? 4. The output as in the y coordinate is 4. For the next one, Shakiba. What is the next one? When x equals 3. Well, x equals 3. Do you see a line somewhere on your graph? Yeah. This line will get to x equals 3 here. They don't have to give us a solid dot. It could just be a line, a passing through line. And where is it? Is that the y coordinate of this point? It's 1. Yes. Then that would be a 1. So your output doesn't have to appear as a point. It could simply be a passing through line. Latterly, what about the next one? When x equals 4, what is the output from your function? When x equals 4, here is x equals 4. Would it be this point or that point? The bottom one or the empty one? The bottom one gives us a solid dot. If it is an empty dot, it is not part of the function. We will only look at points that give us a solid dot or a passing through line. So in this case, what is the output? When x equals 4, what is the output? Negative 4? Negative 2. That is the y coordinate of your point. So for the next one, this time, instead of having the x given, they have the output given to us. And that means, right now we have the y value. When y equals 2, what are the x value? Okay, that could be more than 1. Here is y equals 2. Yeah, you see one point here. That's pretty clear cut. You have x equals 5. But do we have another place on the graph? Yes. Where is it?
Like 2.5.
Negative 2.5. So it is possible to have two answers in this case. It will still be a function because we are talking about different x value. No problem when we have different x value. We only want the same output if you are dealing with the same input. But now if we have different input, it doesn't matter if we end up with the same output. So for the last one, this time we have f of x equals 1. Or that means y equals 1. Where do we see positive 1 for the y coordinate?
3 and
Griffin?
3 and negative 2.
3 and negative 2?
I would just say negative 2.
You would just say negative 2?
Yes.
Alright, there is 1 point for sure. And you said positive 3. But could it be 2.5
Oh, it should be the bracket.
or 3.1?
Less than something.
Yeah, less than, bigger than those inequality, right? So we will have x equals negative 2 and anywhere between 2 and 4. Not equal because that's an empty dot.